The next topic which we have to start is the motion curve. You can refer the theory given to you, theory of motion curve, page number 6. They refer that theory. Now, what is the motion curve? When the acceleration of a particle, velocity of a particle, and displacement of a particle are plotted against time, then the graph obtained are known as the motion curve. So, motion curves are nothing but the graph of acceleration versus time, velocity versus time, displacement versus time. Sometimes we can plot the graph of velocity versus displacement also. That is also the motion curve. Yeah. But not in your syllabus, clearly it is mentioned that only AT, VT and ST graph. Okay, so we are going to learn only these three and their properties. Yes, if there is a velocity versus displacement or acceleration versus velocity, here apart from these three, if there is any other graph is given, how to solve that also I will tell you in brief here, but actually that is not a part of your syllabus, but sometimes that may ask in the exam. Okay. Now, why to draw this motion curve? So, these are the graphical methods to solve the sum. Here, same sum can be solved by using the kinematic equations also. But if we solve the question by using the kinematic equations, sometimes it becomes very lengthy. Okay, and this is the easy. If you know the property of that motion curve, here this method is very simple and easy to solve some type of question. Which type of questions can be solved by using the motion curve easily, or for which type of sums the motion curve, this method is suitable. For example, suppose one particle is starting from origin, moving along the straight line, this O is the origin, and up to certain time or up to certain distance, the particle is moving with a variable acceleration like A equal to 0.5 t. Then from A to B, it is moving with a constant acceleration. यहाँ पे जो acceleration आएगा, it maintains that acceleration, so acceleration remains constant. Now after B to C, here its velocity remains constant, that is acceleration equal to 0. And from C to D, it is decelerating, that is with a negative acceleration, and come to rest. Means here the particle is continuously in motion. Okay, but the type of motion or its acceleration varies in different interval. In this interval, the acceleration is different. In this interval, acceleration is different. Here the acceleration is different. Here the acceleration is different. Here the type of motion is also different. From O to A, it is variable acceleration motion. From A to B, it is a uniform acceleration motion. From B to C, it is a uniform velocity motion. And this is again the uniform acceleration motion, but it is a decelerating. Now, in such type of question, here you have to analyze each interval separately. O to A separately, B to C separately. क्योंकि इसके लिए जो equation of motion लिखेंगे, that equation of motion will not be valid from A to B, because from A to B it is a uniform acceleration motion. Yes, this equation of motion will not be valid from B to C. So in such type of questions, if you write the equation of motion for each part, here the sum becomes too lengthy. And that's why here whenever the acceleration is different in different interval of time, yes, it is always better to solve such type of questions by using the motion curve. Motion curve is suitable for that. Okay, here, so when the acceleration is different in the different interval of time, here we can solve the sum by using the motion curve. Here, आपको ऐसा भी क्वेश्चन आप मोशन कर्व से सॉल्व कर सकते हैं, और यू कैन सॉल्व बाय यूजिंग द इक्वेशन ऑफ मोशन आल्सो. यह क्वेश्चन में ऐसा दिया नहीं रहेगा. ओके, नॉर्मली जो क्वेश्चन मोशन कर्व का क्वेश्चन आता है उसमें क्या रहता है, दिस एक्सेलरेशन वर्सेस टाइम डायग्राम वुड हैव बीन गिवन. हियर फॉर वन पार्टिकल द एक्सेलरेशन इज वैरिंग लाइक दिस. फाइंड आउट द करस्पॉन्डिंग वेलोसिटी वर्सेस टाइम डायग्राम एंड डिस्प्लेसमेंट वर्सेस टाइम डायग्राम. मतलब तीनों डायग्राम में से कोई भी एक फिगर दिया रहेगा, and it may ask to draw some other figure. Okay, here such a questions may ask in the exam, and that mandatorily you have to solve by using the concept of the motion curve. Here, and to solve such type of questions, you should know the properties of the motion curve. Okay, So now I'm going to explain you which are the different properties of the motion curve. Which are the different properties of the motion curve. So first, let's consider the acceleration versus time. Let's consider the AT curve. Commonly it is known as a AT curve. Now let's consider one particle is moving along the straight line such that its acceleration is a function of time t. Let its acceleration is a function of time t. It may be any function. It may be the linear function, quadratic function, cubic function, कुछ भी रहेगा. Now for this, let's example, suppose a equal to 0.5 t plus 3. ऐसा एक equation है. Now for this equation, for this variable acceleration, if I plot the AT curve, here क्या आएगा AT curve इसका? Now it is a linear equation. Means AT curve will be a straight line whose slope is 0.5 and y-intercept is 3. Here means AT curve will be like this, isn't it? I hope that you are comfortable with this equation of straight line and equation of parabola and all these things. Okay, so this becomes the AT curve for this. Yeah. अभी ऐसा अगर AT curve है, तो what will be the nature of the VT curve? VT curve कैसे आएगा? What will be the nature of ST curve? वो कैसे plot करने का? So for that, I am going to explain you here in general term. I am going to explain you the different properties of this motion curve. Here, so let's consider the first AT curve. Let one particle is moving the straight line such that the acceleration is a function of time t. Now let's plot the acceleration versus time diagram for this equation. This is the AT curve, and this is the curve whose equation is acceleration is a function of time t. It may be linear, it may be the parabolic, or it may be the hyperbolic, or any function. Okay, this is not the path traced by the particle. Make it clear. This is the how the acceleration varies with respect to time. It is the acceleration versus time diagram. Okay. Now let that particle is moving along the straight line whose acceleration is changing like this. Now let at any time t1, let the velocity is v1. And since the acceleration is changing, so after time t2, let the velocity become v2. At time t1, the velocity is v1. ये velocity नहीं है. At this point, the acceleration is a1, and here the acceleration is a2. v1 and v2 are the velocities at that time t1 and t2 during this motion. Yep. Now we know that acceleration for this equation of this curve, here the equation of this curve is acceleration is a function of time t. Yep. We know that the acceleration is dv by dt. We can write acceleration equal to dv by dt, which is f of t. Now let's separate the variables. So we can write down dv equal to f of t into dt. dv equal to f of t into dt. Now integrating both sides. Integrating both sides. Now if I integrate, now for this motion, here I know that when t equal to t1, the velocity is v1. Here and when t equal to t2, the velocity becomes v2. Isn't it? Here I make that indefinite integral by substituting the limits. I make it definite integral. Here मैंने limit substitute किया. Okay. Last 5 question, variable acceleration में हमने instead of substituting the limits, here we have solved it as an indefinite integral only. Here लेकिन यहाँ पे मैंने limit substitute किया because I assume that at time t1 the velocity is v1, at time t2 the velocity is v2. Now if I solve this equation, here then this left hand side integration of dv from v1 to v2, if I solve that, I will get on left hand side v2 minus v1. v2 is the velocity at time t2 and v1 is the velocity at time t1. So this gives you the change in velocity from t1 to t2. So it is v2 minus v1, which is equal to, it is integration of f of t dt, which is the equation of this curve. इसके equation को हम लोग integrate कर रहे हैं from limit t1 to t2. Now you know that when we integrate the equation of any curve from limit t1 to t2, so what this integration represents? किसी कर्व के इंटीग्रेशन कर्व के इक्वेशन को अगर हमने इंटीग्रेट किया here from some lower limit to higher limit, तो ये क्या देता है? क्या देता है?
Area.
It represents the area under that curve. क्या represent करता है? Area under that curve. Okay. So from this one, the first property of the AT curve can be written as area अंडर एटी डायग्राम, एरिया अंडर एटी डायग्राम, अगर आपने एरिया अंडर एटी डायग्राम अगर कैलकुलेट करते हैं तो दैट एरिया अंडर एटी डायग्राम गिव्स यू द चेंज इन वेलोसिटी इन दैट इंटरवल। जो इंटरवल के बीच में का आप एरिया कैलकुलेट करते हैं तो दैट एरिया रिप्रेजेंट्स, एरिया अंडर एटी कर्व represents the change in velocity. It is the change in velocity. Here the area under 80 curve will not give you the absolute velocity at any instant. It will not give you the instantaneous velocity. But the area under 80 curve gives you the change in velocity. Okay. So area under 80 curve gives you the change in velocity. Remember this first property of the 80 curve. Area under 80 curve gives you the change in velocity. Any doubt? Okay. Second, suppose one particle is moving along the straight line such that here the 80 curve is like this. This is the 80 curve. Now this is the time where the acceleration is 0. Let that time is t1. What is happening at time t1? The acceleration is 0. The acceleration is not only 0, but the acceleration changes its sign from positive to negative. Okay. Here from 0 to t1, इधर ध्यान दो अभी. From 0 to time t1, the acceleration is positive. उसका magnitude decrease हो रहा है, but still acceleration is positive only. यार अभी acceleration अगर positive रहता है, तो what happens with velocity? If there is a positive acceleration, what happens with the velocity? सो गए सब लोग, ब्रेकफास्ट करने के लिए गए।
It increases, sir.
It increases. Okay. Here when the acceleration is positive, the velocity has to be increased. Okay. अभी मैं नाम लेके क्वेश्चन पूछूंगा। So remember, when the acceleration is positive, the velocity increases. Means from 0 to t1, अगर मैं इसका velocity versus time diagram अगर plot करता हूँ, तो from 0 to t1 the velocity goes on increasing, and at t1 the velocity is, acceleration is 0. लेकिन उसके बाद में क्या हो रहा है? The acceleration is negative, isn't it? After t1 the acceleration is negative according to the graph, and after t1 since the acceleration is negative, what will happen with the velocity? The velocity goes on decreasing. Here, so this is approximate velocity versus time diagram when this is the 80 curve. Now conclusion is that here at the time at which the acceleration is 0, not only 0 but it varies its limit, varies its value from positive to negative. At the time at which the acceleration changes its sign from positive to negative, at that time the velocity is maximum. यार मॉर्निंग लेक्चर में मैंने बताया था आपको कि फॉर मैक्सिमम वेलोसिटी द एक्सेलरेशन हैज टू बी 0. ओके यार, तो related to the motion curve I can conclude that the time at which the acceleration is 0 or the time at which the 80 curve changes its sign from positive to negative, here at that time the velocity will be maximum. अगर velocity time diagram plot करने का है तो ये point you have mandatory to show this point. Okay. Now, अगर ऐसा ग्राफ है, this is the 80 curve, this is straight line है. Now, this is the time t1, where again the acceleration is 0, but there is a difference between these two. Okay, so in second graph from 0 to t1 the acceleration is negative, and after t1 the acceleration is positive. But in both the graph at time t1 the acceleration is 0. Here, now in this second graph, can you tell me at this time t1 where the acceleration is 0, here how much is the velocity? Velocity क्या रहेगा यहाँ पे? Second graph में, at the first graph I said, at time t1 where the acceleration is 0, the velocity will be maximum. Second case में भी वो velocity maximum रहेगा क्या? उधर भी acceleration 0 है.
No sir. Minimum sir, minimum.
The velocity will be minimum. Here velocity minimum रहेगा. Because initially there is a negative acceleration. Negative acceleration means the velocity goes on decreasing. And उसके बाद में positive acceleration means after this time t1, here the velocity goes on increasing. So at this time the velocity will be minimum. Okay, so the second property of the AT curve क्या लिख सकते हैं हम लोग? Here the time at which acceleration is 0, here the velocity will be कैसा रहेगा? The velocity will be either maximum और minimum. एक तो maximum रहेगा या तो minimum रहेगा. Maximum कब रहेगा? If the AT curve changes its sign from positive to negative. And minimum कब रहेगा? When the AT curve changes its sign from negative to positive. Okay? Any doubt?
No, sir.
Okay, so these are the two important points or properties of the AT curve. एक तीसरा भी point उसमें theory में लिख के दिया है. It is given that the AT diagram can also be used for calculating the position of the particle at any time by using the formula. वो formula भी दिया है, बहुत लंबा चौड़ा formula है. Okay, here with the help of this AT curve, area under AT curve, we can calculate the change in velocity. Similarly, with the help of this area under AT curve, we can calculate the change in displacement also. मतलब directly AT curve से भी हम लोग directly change in displacement calculate कर सकते हैं. If time permits, I will tell you that later. Yeah, but बहुत rarely normal book में आपको मिलेगा भी नहीं वो formula. जो formula इधर दिया है, you will not get in its normal book. Okay, in normal book में यही है, AT curve से VT plot करो और VT से displacement time diagram draw करो. ये फार्मूला से आप डायरेक्टली AT से डिस्प्लेसमेंट टाइम डायग्राम ड्रॉ कर सकते हैं, या तो AT कर्व से डायरेक्टली आप चेंज इन डिस्प्लेसमेंट या तो डिस्प्लेसमेंट कैलकुलेट कर सकते हैं. अंडरस्टूड? क्लियर? ये फार्मूला से आप वेलोसिटी कैलकुलेट कर सकते हैं, चेंज इन वेलोसिटी कैलकुलेट कर सकते हैं. ओके, विल डिस्कस अबाउट दैट फार्मूला लेटर इफ टाइम परमिट. फॉर टाइमिंग जस्ट रिमेंबर दिस टू. द नेक्स्ट वन इज द VT कर्व. व्हिच आर द डिफरेंट प्रॉपर्टीज ऑफ द VT कर्व? Now let's consider the particle is moving along the straight line such that the velocity is a function of time. Velocity is a function of time. So for this, if I plot the graph, velocity versus time diagram, if I plot, here I am considering the same curve whose equation is V equal to f of t. So at this time t1, when the velocity is v1, let the displacement is s1, and at time t2, let the displacement is s2. Okay, and the same procedure, this v is given as f of t. This v can be written as ds by dt. If I separate the variable, so ds equal to f of t into dt. If I integrate them on both the sides, here now for this, let's assume that when time t is t1, the displacement is s1, and when time is t2, the displacement is s2. Okay, so from this one I can write down, here left hand side is the integration of ds from s1 to s2, which gives you the s2 minus s1, which is equal to here integration of f of t dt from limit t1 to t2. अभी this is the equation of VT curve. SAT का equation नहीं है ये. This is the equation of this VT curve. Now, if this is the equation of VT curve and we are integrating it from limit t1 to t2, so this integration gives you the area under VT diagram. So from this one, I can conclude that for VT diagram, the first property is the area under VT curve. What it represents? It represents the change in displacement. It represents the change in displacement. So area under VT diagram represents the change in displacement. Here area under VT diagram will not give you the displacement at any point or at any instant. It will give you the change in displacement. So area under VT diagram gives you the change in displacement. Here similar. Any difficulty? And just now in the morning lecture I told you that the change in displacement sp2 minus sp1, here it also gives you the distance traveled. It is the distance traveled, isn't it? Here, so we can say that the area under VT diagram is the change in displacement, or you can say that it is the distance traveled by the particle in that interval of time. Okay, the first property of the VT diagram. Second, let's consider this concept only. Now, if I plot the VT diagram, and suppose this is the VT diagram, this is the time t1 where the velocity is 0. Okay, can you conclude something from that graph? What happened at time t1? What is happening at time t1?
Velocity is
Maximum
minimum.
displacement.
Maximum displacement, correct. Again, मॉर्निंग में बोला मैंने, मुझे वो स्पेसिफिक आंसर चाहिए. मैक्सिमम डिस्प्लेसमेंट रहेगा, यू आर राइट.
Particle changes its direction.
राइट. मैंने मॉर्निंग में बोला आपको कि व्हेन द पार्टिकल रिवर्स इन डायरेक्शन ऑफ मोशन, यहाँ पे वेलोसिटी 0 रहता है. उसके पहले वेलोसिटी में भी पॉजिटिव, इसके बाद में इट विल बिकम निगेटिव. Okay, here, so the time at which the velocity is 0 or the VT diagram changes its sign, here at that time the displacement is maximum and the particle reverse the direction of motion. Here, the question line में क्वेश्चन है, ऐसा पूछा है कि find out the distance traveled by the particle here till the time the particle reverse the direction. जब ये reverse करता है, यहाँ तक का ही distance travel calculate करने का है. Here means how we can calculate the distance travel from the VT diagram? It is the area under VT diagram. लेकिन कौन सा एरिया लेने का है? क्योंकि टेक ओनली दिस मच एरिया, जहाँ पे पार्टिकल रिवर्स करता है वहां तक का है, ये एरिया नहीं लेने का है. Understood? Here, so the time at which the particle, the velocity diagram changes its sign here, or the velocity 0, at that time the particle reverse the direction of motion. Here, the time at which particle, or the time at which VT diagram changes the sign, the time at which the VT diagram changes the sign, here at that time क्या होता है? The first thing, ये लिखता हूँ उसको, the displacement is maximum, and B point क्या होता है? Particle reverse the direction. Particle reverse the direction. समझ में आया क्या दोनों पॉइंट? Have understood this? Okay. Now let's consider this VT diagram whose equation is g as a function of time t. Okay. अभी ये ग्राफ का at this any time t, at this point I want to calculate the slope of this curve. क्या कैलकुलेट करने का है मुझे? Slope of curve or slope of VT diagram. Yeah, if I know the equation of curve, how I can get the slope of curve? अगर किसी कर्व का इक्वेशन पता है या तो उसका स्लोप कैसे कैलकुलेट? डिफरेंशिएटिंग. Okay, so here the slope of VT diagram, here I can get by differentiating this equation at time t. Here so slope of VT diagram can be written as dv by dt. Am I right? Because I know the equation. अगर इसको इक्वेशन को डिफरेंशिएट किया और वो इक्वेशन में t का वैल्यू अगर सब्स्टिट्यूट करता हूँ तो I will get the slope of this curve at that time t, isn't it? Yeah, but what is dv by dt? So dv by dt is nothing but a acceleration. Yes, so what we can conclude about the VT diagram, the third point, here slope of VT diagram, क्या रिप्रेजेंट करता है? Slope of VT diagram मतलब dv by dt. What it represent? So it represents the acceleration at that particular time. Slope of the VT diagram, किसी भी पॉइंट पे अगर VT diagram का स्लोप कैलकुलेट किया तो वहां पे वो टाइम का आपका उसको एक्स्ट्रा एक्सेलरेशन मिलेगा. You will get the acceleration at that particular instant of time t. Okay, so the slope of VT diagram represents the acceleration. Here any doubt? ये सब आपको याद रखने का है. मोशन कर्व का अगर सम सॉल्व करने का है तो all these points you have to remember. Okay, slope of VT diagram represent the acceleration. ये 3 point enough है for VT diagram. Area under VT diagram represent the change in displacement of the distance traveled. The time at which the velocity change, VT diagram changes its sign at that time, the displacement is maximum, and a particle reverse the direction of motion. And third point is the slope of Vt diagram at any time t. Here gives you the acceleration. Okay, here slope of Vt diagram represent the acceleration. Any doubt? Understood?
Yes, sir.
Okay. Now the last one is the ST diagram. ST diagram. Here एक ही मिनट में फिनिश करने वाला हूँ. Let the equation slope of equation of this curve is S is a function of time t. Here area under ST curve will not represent any physical parameter or physical quantity. Here just the slope of ST diagram at any time t. The slope of ST diagram which is equal to ds by dt. And what is ds by dt? It is the velocity. Here एक ही पॉइंट आपको याद रखने का है फॉर ST कर्व. Here for ST curve, slope of ST diagram. ST diagram is displacement versus time diagram. The slope of ST diagram represents the velocity at that instant. Okay. Any difficulty? Now when most of the time in the question, any one out of that three curves are given, and you have to ask to plot the remaining two. Now, whenever such a question is there, what I am suggesting, plot all the three curves one below another. Here, on left hand side of your book or answer sheet, left side पे तीनों कर्व प्लॉट करने का. Here और तीनों प्लॉट सेम सीक्वेंस से ही प्लॉट करने का, चाहे कुछ भी देने दो. Here पहले 80 कर्व प्लॉट करने का. अगर नहीं दिया है तो लीव द स्पेस फॉर दैट. देन उसके नीचे ही y एक्सिस एक ही लाइन में लेने का है. Here below that plot the Vt diagram and below that plot the ST diagram. You have to plot all the three curves one below another because it becomes easy to correlate them. Here ऐसा नहीं करने का है कि given AT diagram, then calculation, then VT diagram, then calculation and then ST diagram. Here don't do that. Here draw all the three figures one below another, and that too also on left hand side page only. Because while doing the calculation, we have to do this. We have to refer this graph number of times. और अगर आपने ये पेज पे graph plot किया, and if you do the calculation on the opposite page, the number of times you have to turn the page. And in that, while turning and writing, definitely you will do some mistakes. Yes, so to avoid that mistake, here what I am suggesting, plot all these three diagrams on the left hand side page and related calculation on right side. And all three figures one below another, and यही sequence में plot करो. पहले AT, उसके नीचे VT और ST. Here अगर VT दिया है तो इसके लिए space छोड़ दो, फिर VT plot करो, and then ये ST के लिए space छोड़ दो, and then start the calculation. Understood? Any doubt? Now, I am considering 2-3 intervals here from 0 to T1, T1 to T2, T2 to T3. I am projecting this because for this interval only I have to plot the VT and ST diagram. Okay, so this is time T1, T2, T3, T1, T2, T3. Okay. Now, in general form, generalize. Here, let y is a function of x. Let y is a function of x. अगर मैं ये इक्वेशन को डिफरेंशिएट करता हूं, या तो ये इक्वेशन को अगर मैं इंटीग्रेट करता हूं, यार, तो क्या होता है? Just remember, when we integrate any equation, the degree of the equation increase by 1. अगर ये लीनियर है तो ये क्वाड्रेटिक बन जाएगा, अगर ये क्वाड्रेटिक है तो ये क्यूबिक बन जाएगा. ओके यार, so whenever we integrate any equation, its degree is increased by 1. Whereas when we differentiate the equation, the degree is decreased by 1. Okay, here, am I right or not?
Yes, sir.
Okay, so when we integrate any equation, the degree is increased by 1. Yeah. Now let's consider this concept we have to apply here. Let's consider acceleration is a function of time t. I am considering it as a linear equation. A equal to 0.5 t. ओके क्लियर. अगर a इक्वल टू 0.5 t है तो इसका ग्राफ कैसे आएगा, AT डायग्राम कैसे आएगा? कैन एनीबॉडी टेल मी?
लीनियर.
लीनियर आएगा. कहां से पास होगा?
ओरिजिन.
ओरिजिन में से. और क्या क्या पता बोल सकते हैं अबाउट दैट लीनियर ग्राफ?
स्लोप हाफ.
स्लोप हाफ रहेगा. करेक्ट. गुड. So there will be one 0.5. Let I am considering up to t1. It follows this equation. It is an oblique straight line. Here because this is the equation of straight line passing through the origin a equal to 0.5 t. अभी ये करस्पॉन्डिंग AT डायग्राम के लिए मुझे VT डायग्राम प्लॉट करने का है. ओके यार, अभी जब मैं VT डायग्राम प्लॉट करूंगा तो टू गेट दैट इक्वेशन ऑफ द VT को मुझे इसको इंटीग्रेट करना पड़ेगा. Isn't it? Here, so V equal to integration of A into dt, which is equal to 0.5 t square upon 2. Am I right? Plus some constant of integration, and let us assume that it is 0. Here, so this becomes the equation of this VT curve. This is the equation of VT curve. Am I right? Clear? मतलब जब AT डायग्राम अगर लीनियर इक्वेशन है, अगर लीनियर कर्व है, corresponding VT diagram will be a second degree equation or it will be a parabola. Okay, here and what will be the corresponding ST diagram? अगर मुझे इसमें से यही same motion है पार्टिकल का, सिर्फ I have to write down how the velocity and displacement varies with respect to time. Okay, तो अगर VT से मुझे ST का इक्वेशन लिखने का है तो मुझे इसको फिर इंटीग्रेट करना पड़ेगा with respect to t. So this f becomes 0.25 t cube upon 3. So it becomes the cubic equation, isn't it? Here, so from 0 to t1, the ST curve will be a cubic curve. ये आएगा parabola, and this will be a cubic curve. Listen to me. Just by observation, nobody is going to tell if whether it is a parabolic curve or the cubic curve. To identify between the parabola and the cubic curve, here you have to write down the equation. From the equation only you will come to know that whether it is a parabola or cubic curve. Just by observation you can't say. ऐसा कुछ नहीं रहता है कि पैराबोला शैलो रहता है एंड क्यूबिक का ऐसा डीप रहता है, ऐसा कुछ नहीं है. ओके हियर, सो व्हाट इज द अल्टीमेट कंक्लूजन ऑफ दिस? व्हाइल प्लॉटिंग दिस कर्व, द डिग्री ऑफ VT कर्व, लिसन केयरफुली, द डिग्री ऑफ VT कर्व इज 1 degree more than AT and degree of ST curve is 1 degree more than VT. Here when we move down, here कर्व का डिग्री 1 डिग्री से बढ़ जाता है, ऐसा याद रखो. It means that if AT diagram is an inclined straight line, the corresponding VT will be a parabola or it is a curve of degree 2, and corresponding ST curve will be a cubic curve, that is a curve of degree 3. Okay, here now from T1 to T2, if the AT curve is a horizontal straight line, मतलब if acceleration is constant, yes, constant है मतलब it is a straight line of 0 degree. This is a straight line of degree 1. This is a straight line of degree 0. Here, so अगर AT curve is a horizontal straight line है, here so VT curve will be an inclined straight line, इससे 1 डिग्री ज्यादा, and corresponding ST curve will be a parabola, उससे 1 डिग्री ज्यादा, 1 डिग्री से बढ़ जाता है. Understood? Now from T2 to T3, अगर acceleration 0 है, if suppose acceleration is 0 from T2 to T3, here अभी अगर acceleration 0 है, here what will be the nature of VT diagram? Acceleration 0 है मतलब velocity remain constant, isn't it? Acceleration 0 है मतलब velocity remain constant. और अगर VT का अगर horizontal straight line है तो corresponding ST curve will be a inclined straight line. It is a curve of degree 1. Understood? So इतना ही याद रखने का है कि degree of VT curve is 1 degree more than AT and ST curve का nature is 1 degree more than VT. एक डिग्री से कम होता है when we move from top to bottom. Here और bottom से top अगर जाएंगे तो एक डिग्री से कम होते जाएगा. Okay, yeah. Now I will tell you कि सर अभी क्वेश्चन ये आएगा कि सर अगर ये इंक्लाइन स्ट्रेट लाइन है तो आपने ये पैराबोला ऐसे ही क्यों ड्रॉ किया? कॉन्केव अपवर्ड क्यों ड्रॉ किया, ऐसे क्यों नहीं ड्रॉ किया, व्हाई दिस पैराबोला इज नॉट लाइक दिस, व्हाई इट इज लाइक दिस ओनली, दैट आई विल टेल यू व्हाइल सॉल्विंग द सम. बट हैव यू अंडरस्टूड दिस concept? Any doubt? So while solving the sum on motion curves, you have to remember all these things. Here motion curves sums you can solve by using these properties, or for each interval जिसमें ये motion continuous है, ये देखो from 0 to t1 the motion is continuous. Equations are valid from 0 to t1, लेकिन t1 पे equation type of motion change हो रहा है, type of motion change हो रहा है, इसलिए equation of motion are also changing. Means I can say that from 0 to t1 the motion is continuous, from t1 to t2 it is continuous, from t2 to t3 it is continuous. Yeah, so ये questions can be solved by using the properties of the motion curve, or the same question can be solved by writing such type of equations also. ओके क्लियर. यहाँ से 0 टू t1 के बीच में ये दिस द वेरिएबल एक्सेलरेशन मोशन, फ्रॉम t1 टू t2 यूनिफॉर्म एक्सेलरेशन मोशन, एंड फ्रॉम t2 टू t3 कौन से टाइप का मोशन है ये, इट इज अ यूनिफॉर्म वेलोसिटी मोशन. एक्सेलरेशन 0 है मतलब इट इज अ यूनिफॉर्म वेलोसिटी मोशन. ओके, तो हर एक इंटरवल के लिए इक्वेशन लिख के भी आप क्वेश्चन सॉल्व कर सकते हैं. अंडरस्टूड? एनी डाउट? ये समझ में आया क्या, मोशन कर्व का प्रॉपर्टीज समझ में आया क्या? ओके, नाउ विल सॉल्व वन सिंपल क्वेश्चन. Okay, we'll continue in the next lecture. We'll stop here now. This sums lengthy samay, not possible to finish in 10 minutes. We'll continue. Do you have any difficulty? जो भी हमने आज लिया उसमें कुछ difficulty है क्या? By this weekend till Friday, almost we are going to finish this lesson. Okay, for your test will be in the next week I think. आप लोगों को टाइम टेबल मिला क्या, मतलब डेट्स मिला क्या टेस्ट का? आई एम नॉट श्योर बट इट इज फ्रॉम 8th of March समथिंग, योर फर्स्ट इंटरनल असेसमेंट टेस्ट.
सर हमें 12th बोला था.
12th है क्या? हाँ 12th होगा.
हाँ 12 to 15.
12 to 15. So by 12th definitely we are going to finish all the 3 lessons completely: centroid, resultant and kinematic of particles. Okay. Any doubt? Okay, thank you.
सर ये लेक्चर और इसका प्रीवियस लेक्चर क्लासरूम पे अपलोड कर दो ना प्लीज.
हाँ चल देगा, ठीक है.
थैंक यू सर.
क्योंकि वो गूगल से आने के लिए ही टाइम लगता है. बाय इवनिंग आई विल गेट दैट एंड देन आई विल अपलोड.
ओके सर.
ओके फाइन.